Hello, everyone. I am here today with Katherine Forsey, research biologist, education and outreach specialist, and Chief Research Officer for the Charcot-Marie-Tooth Association in the USA. So, Dr. Katherine Forsey, first of all, can you tell us a little bit about yourself? We'd love to hear, a bit about your career history to date, and what's led you to where you are today.
Hi, Katie. Thank you for inviting me to come and talk with you. It's really lovely to be here. So yes, you're right. I have had a mixed career in history that's sort of led me to where I am, and I'm always happy to talk about it. Um, I'm a research biologist by training. So I went to the University of York to study molecular cell biology. So I've wanted to be a scientist since I was 11. I told my mum, she tells me when I was 11, I want to be a scientist, mum. And they don't know where that came from because like mum was a childminder and had a little tea shop, and my dad worked for British Aerospace, um, riveting aeroplane fuselages. So there was no science in my background. I'm the first in my family to go to university. And I just, science hit me really young. I think it was a primary school teacher who was just really brilliant at all the practical science, and I loved it. And then
Yeah,
I
it's really
carried that all the way
fascinating.
through. Yeah, I carried it all the way through A levels in science subjects and applied to go to a few different universities, looked around several, picked York, fell in love with the city. It's such a beautiful campus. And yeah, I did my undergraduate degree and I applied for the 4 year course. So I did a year in industry and I
Mhm.
spent a year working at a company called Syngenta. It's a genetic toxicology company. It was in Macclesfield. So off I went for a year to the outskirts of Manchester, and I did my year there and I was running my own research project. I was developing a new experiment that meant we didn't need to use animals. So it was a in vitro assay. So it was in the dish with cells instead of the animal tests because they were testing agrochemicals, and that's all governed by law. You know, you have to do certain types of tests. So I was helping to develop a new test. And I loved it. And I came back from that year in industry and I spoke to my undergraduate supervisor. He was called Professor Henry Lees. And I said, I love that year. I'd love to do more research. How can I do more of that? And he said, have you ever considered doing a PhD? I was like, what's a what's a PhD and what does that mean? And let's have a chat about it, and discovered what a PhD was. And he said, actually in our lab, we'll have a PhD position for the year after you graduate, if you'd like to think about applying.
Brilliant.
So, yeah, talked with my family. They asked the same questions. What's a PhD? When are you going to get a proper job? Um, so I was really fortunate. I applied. It was an industry funded PhD. So I was sponsored through my PhD, stayed in York for that, but I
Mhm.
also spent around 9 months of that 3 years in different chunks at the University of Cambridge,
Mhm.
about a month in the Czech Republic at a veterinary research institute where we were gathering samples. Um, and the PhD is really hard. Like
Mhm.
it's one of the most difficult things I've ever done, because you're having to push the boundaries of research and discover new things. Like it's not a PhD unless you discover something new and you're investigating and really like moving science forward. So
Interesting.
I loved it. I love my PhD. It was hard. It was one of my like proudest achievements because there were times when I never thought I'd finish it. So anybody who's going through a PhD will know exactly how that feels. But you just keep on going, and eventually, you write your big fat thesis book and defend it, and you get your PhD in the end. And I finished my PhD, and I'd really come to the conclusion because I'd done some volunteer work for the university as a graduate teaching assistant and working on summer schools for children who would come to the university in the summer.
Mm.
But I really liked communicating science, and
Mhm.
a few people had said to me, "Oh, why don't you think about being a teacher? Like you're really good in this environment." But a few people I knew had gone on to teaching and not really loving it, and I just thought I want to find another way of sharing science. And then whilst I was finishing writing my thesis, a job came up in an education and outreach role, for a non-profit for a charity in the UK, and I investigated that. And one of the drivers for that was getting out. I love people, and a lot of my PhD was spent in a small dark room doing like fancy microscopy techniques or investigations where you
Experiments.
have to be in a little space on your own for hours and hours. And you come out of it like blinking into the light. And I just thought, I just really want to do something that works more with people, where I can be out and communicate in science more. So yeah, like I started work at the Yorkshire Arboretum as their education development officer, first role for them. They didn't have anybody before me in that role. That's a little bit of a pattern, I think, in my work. So I got to found it, started it from nothing and build it up. And I was there for 5 years. And I think in that time we welcomed about 20,000 children on visits. So it was zero to thousands of children coming through the doors on school trips. And just the whole management and growth of that program was brilliant. And I loved working with them. But I'd been there about a year when I was approached to do some consultancy work. And it was going to be 1 day a week for the Woodland Trust, which is a huge charity in the UK, big in that sector. Talked to my family again. They're like, "You've only had a proper job for 1 year, and you're already talking about going full like part time." So it's like, "I promise you, Dad, I've done my sums. It will be fine. I want to take this chance." And I've never looked back from there. I
Wow.
Until now, I had 15 years of never been full time. I was always doing a job for some people and a job for somebody else. And
Yeah.
after that contract finished with the Woodland Trust, I went to work for the ASE, which is the UK's Association for Science Education, who promote excellence in teaching and learning in science. Because I'm a subject specialist, a biologist, PhD, I was able to bring all that subject specialism, but also that passion for sharing it.
Mm.
I worked with them for a few years. And then that led me into a job with the National STEM Learning Centre, which is the UK's largest STEM science education training provider. And my role was actually working on a programme for technical staff in higher education. So I was back into the higher education field.
Yeah.
All these specialists, scientists, engineers, all working with them and making sure they were getting the training and development they needed. And that was a national role. So I loved sort of working at that national level.
Mm.
But my consultancy work was kept on the side and it kept building up. I
Mm.
had my son, so maternity leave, and picked up more consultancy work as you do while you're on maternity leave, or maybe just as I did. I don't know. Um, and that consultancy work just kept growing. Clients kept getting busier, and I had to kind of make a decision at one point whether I was going to go fully into being self-employed or stay where I was. I was actually pregnant with my daughter at the time, about 8 weeks pregnant when I stepped down from my proper job. And again, the questions were answered, why don't you just stay and have your nice maternity leave? But
Yeah.
I had this
Make things easy for
opportunity.
yourself.
I just don't think that's what I ever do. And I just took the leap. The opportunity I had with some clients wasn't going to be around forever, wasn't going to wait a year. So I went for it. And I had my daughter, and at 3 months old, I was sort of back doing a day
Yeah.
or two a week, but on my own choice, my
Yes.
own events, my own clients. And I was really fortunate that I got a really supportive mum um, who she'd been made redundant from her job at the banks. The banks are always making people redundant.
Indeed.
So she had a little bit of time that summer to help me out. And we just sort of managed it until my daughter was old enough to have a little bit of time in nursery.
Yeah.
And I was self-employed for 3 years, fully self-employed, just running my own business, and absolutely loved it. Then we went into COVID, and everybody knows the joys of COVID. Um, Came out the back of COVID and was picking things back up again. Picked up a role with the University of York, regionally leading one of their programs,
Mm.
and again, sort of in working with industry this time, and really getting to speak to those industry specialists. And yeah, it that kind of led me until everything happened with this Charcot-Marie-Tooth Association, which I think we'll probably come on to in a minute. But that was kind of what got me to that point, was a
Right.
really kind of crazy paving path of just taking opportunities where they came and growing in the types of roles I was doing. But yeah, it was a really interesting path, and I'd certainly encourage anybody who's thinking about science to study university or apprenticeship and sort of think about how where they can take their science.
That's amazing. And as you say, what an interesting career path. And I think really inspiring because it shows particularly for younger audiences, yeah, that there are so many different areas that you can, move from. And just because you don't take the traditional route doesn't mean you're not going to have a rich and interesting varied career. And likewise, if you do take a permanent job, there are many opportunities that can supplement that and enrich it as well. So that's fascinating. Just before we come on to I'd love to hear a little bit more about your personal connection to CMT, but just one quick question. I was really inspired hearing kind of, your passion for educating others and sharing the value and interest of science. What do you think are some of the ways that we might be able to engage more young people in the sciences?
Well, I've been a STEM ambassador. Like the
Mm.
UK has a national STEM ambassador program. I think I've been a STEM ambassador since about 2000, maybe. For a good 20 years I've been a STEM ambassador. It's crazy. So there's all sorts of opportunities. My personal belief is through hands-on, practical, engaging science. So
Mm.
getting out with a pond dipping net and finding what invertebrates are living in the water,
Yeah.
sticking a lab coat on and doing a few experiments at the desktop, getting things out your kitchen cupboard and getting the bicarb and vinegar going with my kids, just to kind of, there's loads of really interesting practical science experiments that you can do that just blows children's minds. Like I see it with
Oh,
my own two. They're 5 and 8, and there's all sorts we can do. I run a STEM club on the weekend on a Saturday, a Lego club at our village library, and we have all sorts of STEM challenges. So like building wind-powered vehicles, or running down ramps, or an egg cup like zip line, with all sorts of things, and it's just those practical opportunities to children are naturally experimental. You
yeah.
see kids from babies, they're always, oh, what works? How does that work? They're so interested. And it's really easy to just tap into that if you do some fun hands-on things. And do you want to have a go at this? And they usually do. And then I drip feed little bits of
Yeah.
science in there and start to build some of their vocabulary. And we start to just expand the way we talk about insects or invertebrates, or like concepts like gravity. You can really start to bring those things in. And I think the UK has a wonderful STEM ambassador program, and that's a
Mm.
really nice way to engage. And we have all sorts of science fairs and festivals. And then just thinking about things that, like I said, that kitchen cupboard science, the things that parents can do, what you can get out and find in your back garden. I think that's just a great way to engage children with the world around them. And you're making science friendly and accessible. It's not some big scary thing that only clever people do in universities or people with white coats. It's every single day all around us is science. And I think that's where we can engage children, and that's the best way to do it.
Brilliant. Thank you so much. So, I would be really interested now to hear about your particular connection to CMT, sort of specifically, and sort of where that interest stems from.
So I think it was about 2018. My sister's health had been deteriorating, and she was struggling with a mobility issues, hip dysplasia. There's quite a lot of neuromuscular things going on, and she finally had a doctor that kind of started to link all of these things together, and did a family history. And my dad has CMT, but it's not something that my dad ever really spoke about very
Mm.
much. He was of the generation where it's kind of like, yeah, but go off and live your life. There's nothing we can really do about it. My granddad had CMT, so I think my granddad was in his 60s when he was diagnosed, and I think my dad was maybe in his 40s. But never really looked into it. I don't think anybody did a family tree with him or talked about implications for his own family. So it was only really in about 2018 when my sister was struggling and they started to join some dots, and she was tested and hers came back positive for CMT1A. And they did, like they should, like a family history, family tree, and started
Yeah.
to map us all out. And she said, oh, well, if your sister's got children, then maybe she might like to consider being tested. Well, I'm a research biologist. I was like, I'm going to roll up my sleeve, take my blood. I'd rather know. Let's see what we're dealing with. And we were all a little bit surprised when my result came back positive, because I'm quite mildly affected. But it does explain why I can't really feel my toes or the soles of my feet. So there's a few things that started to become really apparent. You're not particularly gifted with sports. You would say bit clumsy, cannot walk in heels to save my life. There's a lot of things that started to make sense.
Yeah.
So yeah, and then I had to lobby and convince the genetics counselling service that I wanted my children to be tested, and that's a really personal decision that everybody makes for their own family. But with the way that NHS works and access to some healthcare services in other countries, for me, that knowledge is powerful and knowing what we would need to access. So it then opens the door to early interventions around physio, orthotics, gets them in to see the right specialist. So I had my son and my daughter tested. My son was 4 at the time, my daughter was 1. And the result came back positive for my son. I wasn't surprised because knowing what you're looking for, I could probably have guessed. He didn't jump with 2 feet until he was 4, and like normally we'd look for that around age 2. He wasn't. How did the physios call it? He wasn't accessing stairs in a normal way, which basically meant he was tumbling up like a mountain climber rather than walking upright sensibly. He was 4, so I wasn't really worried too much about that. But
No.
he'd come down on his bottom, things like that. So there were small things that they were starting to pick up. And then when it was investigated, the traditional things come up, like it's really tight in his dorsiflexion, which is, if you imagine an ankle,
Yeah.
it's a really tight joint where he was hypermobile everywhere else. So these things came up, and it then meant that diagnosis meant we could now get to see specialists. So I asked to be referred to Mary Riley down at Queen's Square in London for my care. My son, once I was diagnosed, I asked for him to have a referral to the team at Great Ormond Street Children's Hospital. So we see them. We also see services locally. We're in Yorkshire, so we would go across to Anne-Marie Charles Group in Leeds. And we're able to see those specialists once a year, and they really understand CMT, and they really understand what we can do to help manage our conditions. So yeah, that's my connection to CMT. Was I have it. I found out about 4 years ago. So all of the career history that comes before that, like we had no awareness that anybody had CMT other like than my dad, or we didn't know the inheritance pattern. And I kick myself. I mean, my PhD studied genetics, should really have thought that through. But, it didn't come up on my
No.
PhD course, didn't come up in my undergrad. It's such a rare disease. Nobody really talked about it. So, yeah, my whole path was, I'd love to have studied neurons. That would have been really helpful in my current job.
Yeah.
But, all of the things I did during my PhD are still really, really useful. But yeah,
Definitely.
that's how we're connected to CMT.
Fantastic. Thank you for sharing. Really, really interesting. And there's still time for that neuron research at some point, Katherine. Maybe I sense another little research project coming along down the line. But yeah, and I think the other thing that you really highlighted there, that knowledge is power, is such an important thing. And I think many of our community feel the same. And knowing what it is that you're dealing with enables you to access the right support, to get the right specialists working with you. And you highlighted some of the fantastic teams that are working around the country. And yes, it's really, really interesting to hear. So thank you so much for that. I think that leads us nicely then onto how you found the role at the Charcot-Marie-Tooth Association, and why did that one in particular appeal to you?
So, yes, I mean, I'd found out I had CMT, immediately started to research, finding out like what treatments are there, understanding the biology, what have we got, how has it come about, are there any treatments, like the same thing a lot of newly diagnosed people do. That's what I did, but with my background I went down the research rabbit hole straight away. So of course I quickly came across CMT UK, phoned your office, had that usual conversation of what do we do now, got sent some really useful information. And then as I continued like widening the net of my research, I came across the CMTA, Charcot-Marie-Tooth Association, based in the US, really quickly, because it's the biggest CMT patient advocacy and support and research group. It's been established for 40 years, so their information is vast, and it was so useful and helpful. And I came across their Facebook group as well, so joined their Facebook group. And I'd seen that they run a camp called Camp Footprint for children with CMT, so kids aged 10 to 18, and it runs once a year in the US. Well, I'm STEM ambassador and I was working in education and outreach, and I'm DBS checked and work with children quite often. So I was like, I'll just email and volunteer to go be a camp counselor. I'm usually quiet in the summer holidays. I could pop across and volunteer to do that. Well, first time I emailed, did not hear, and then back because I must have just gone into the internet black hole. And then
Yes.
then we had COVID. So there was like the world of COVID took over. And then we came out of COVID, and the year after I was in this, I saw on the CMTA Facebook group that they were recruiting counselors for Camp Footprint. So this was around January 2022, and the applications opened for counselors. And I filled in an official application form through the proper system, which I hadn't done previously. I just sort of sent an email into a black hole. So I filled in an application form, and I was contacted by Jonah Berger, who's the youth programs director, and he's camp director for the CMTA, and asked me to interview. So I had an interview with Jonah over Zoom. The best half an hour. I mean, that guy is larger than life. He's just a wonderful human. We talked all about camp. We talked about me. He asked me a whole host of questions, and he said, normally we kind of wait till we've talked to a few people, but I want to ask you now. We'd really like you to be a counsellor at Camp Footprints. So I was so happy. So I was like, yay, I'm going to go to camp. So you fly yourself off to camp, and I was really looking forward to it. Well, Jonah emailed me like the day after, or maybe 2 days after, and said, I want you to talk to our CEO, Amy Gray. It was our CEO at the time. Um, she'd like to have a follow-up conversation with you. So I thought, really not, I didn't think much of it because, random British lady applies to be a counsellor at camp in America. They've never heard of me before. Maybe it's just a second wave interview for camp. So had a really good conversation with Amy. We talked for half an hour, I can't even remember now. And then as the conversation evolved, she's asking more about my work history and background. Jonah clearly tipped her off around all of my background. And she starts talking to me about this role that they'd had difficulty recruiting into. They were looking for a specific type of person. And I hadn't quite heard the job title because it was Zoom and it was crackly. And we just sort of chatted along, and I empathized. And there was loads of parallels to the work I was doing with industry, academia, and the translation, and literally like leading programs. And then she said, well, if I send you the job description, would you have a look at it? And that point I went, oh, where would it be based? Because my whole family's in the UK.
Yorkshire.
Yeah, Yorkshire's good. And she said, oh, it's fine. The entire team's remote. They're all spread across different parts of America. We've had somebody before who was based in England. So, I don't think that would be a barrier. And I mean, initially it started off as a consultancy conversation. I had maybe 1 day a week that I had available, and it could have stretched to 2 after a couple of months because I was about to end one client. So it started off as a consultancy conversation, and over 4.5 months, I think I talked to 12 different people at the CMTA. It's the longest interview process I've ever been involved in. Must have been like 12 different people, 12 different interviews, all on different times, different time zones, members of the board, scientific advisors. They had me speak to all sorts of people. And over that time, it just evolved. And then they said, actually, we think we want you full time. So we had that conversation, and it was May 2022. I joined the CMTA as Chief Research Officer. Started part-time because, in the UK, we have to give 3 months notice period, and phased in from my previous clients' jobs, wound down the business. So I've been with them full-time since August 2022. When I went to Camp Footprint and volunteered as a counsellor, because that's the point. That was what I got involved for. And it just so happened that by the time I was at Camp Footprint, I was also on the staff. And that's how I got in touch with the CMTA. So it's about 12, 15 months now that I've been with them. Now done my second Camp Footprint. I'd never miss it. It's just the most wonderful week of the year. But I also have the privilege to be able to help direct and drive the research at the CMTA. So that's why it appealed to me, because I can use all my background to actually make a difference to all of the people with CMT. Like, there's 3 million people in the world with CMT, and there's no treatments, and it's not on. Like, this we've been working so hard over so many years and we are on the precipice of it. But to feel like I can play a small part in driving and pushing that forward, there's no way you can say no to that. As a person with CMT and my background, um, it's just such a great opportunity to really try and make a difference to CMT research.
Amazing, and how fortunate. I know we're all very thankful that you're in that role, and yeah, that the stars aligned. So you really yeah, brilliantly articulated that journey into the role. And can you talk to us a little bit about what the role sort of involves day to day? So obviously, I'm assuming you work on the STAR program, which is the strategy to accelerate research. Would love to hear a little bit more about the objectives of the work currently, and yeah, what you're looking to achieve with this project.
Yeah, so STAR, we just tend to call it STAR, but that is the CMTA's strategy to accelerate research. It was launched in, I think we're looking at 15 years of STAR now. So that was what, 2008, STAR was launched. So I very much feel like I'm standing on the shoulder of giants because it predates me working there. So STAR's been running for 15 years and it has one goal, and that is to develop treatments for CMT. But
Mm.
that one goal is not easy to achieve. So we have a multifaceted strategy to help us get through that. So we have to understand the basic science of CMT. What are the causes of CMT? Like some of them, like CMT1A, okay, you've got a duplication of the PMP22 gene and you've got end up with 3 copies instead of 2, and that causes problems. Okay, so we know that one. And then it's the same for every other type of CMT. Well, now we have over 120 causative mutations for CMT.
Mm.
It's crazy. It's like some diseases just have one, and that's what you go after. With CMT, we have 120, and there's so many mutations involved, and there's so many different types. So most people are familiar with like 1A, 1B, 1X, 2A. They're the 4 most common. That's over 90% of all people with CMT. But then there's all the others, all of the rare types, and we have to think about all of them at the CMTA. We can't just focus on the common ones. So we have to think, how do we understand all of these types of CMT? And then on the other side, we've got the discovery project, because 40% of people with CMT don't know what type of CMT they have.
Mm.
So it's like some nerve conduction and physical studies have said, right, okay, you've got CMT, but the genetic tests, if they've had one, it's coming back. We don't really know. So we're also funding discovery projects. So we work with a team at Stefan Zuckner and his team in Miami in the Inherited Neuropathy Consortium, and they've discovered more than 20 new types of CMT so far. So that's exciting, because when you actually understand the causative mutation, sometimes that points you straight to a treatment. So CMT SORD, the sorbitol dehydrogenase type of CMT, that's a really exciting story. It was 2 years from discovery to a treatment being into clinical trials. So, that treatment's in phase 3 clinical trials, which is amazing. So the more we understand about CMT and its basic biology and its causes, the more we can find targets for treatment. So we have this plan, basic science, and then we go into what they call translational science, which is, okay, so we understand the disease a bit now. What targets of the treatment? Are we going to go for the underlying genetic mutation and try and fix that with genetic therapies, CRISPR, the type of gene therapy technologies people might be hearing about in the news for some of the rare diseases? Or are we going to look for drugs? We would call those small molecule approaches, but drugs, compounds, things that you can swallow or take or inject that are going to somehow help the disease. Well, okay, what are those drugs going to do? What are they going to target? Which things are they going to turn on or switch off to help improve your CMT symptoms? So we have those approaches, discovery, gene therapies, small molecules, but actually we need, how do we know if those treatments are working? So that's another side of what we do. That multi-pronged strategy is natural history studies. So we follow CMT patients over years and we have them do examinations or functional outcome measures. But if anyone's been to their neurologist, you're sort of familiar with push this, pull this, walk along this line, try and do that, the grip tests, all of the different physical exams that you'll do, they have actually been carefully planned and developed over years. And the CMTA supports an organisation called the Inherited Neuropathy Consortium, or INC for short. And they're a whole team of clinicians. So in the UK, that will be Mary Riley, but she chairs the Inherited Neuropathy Consortium. in the leadership team, sorry, of the INC with Mike Shy, who's based in Iowa, and all of the leaders of the Inherited Neuropathy Consortium. They also sit on the CMTA's clinical expert board. So we're fortunate that we get to work with them all the time. They're all heading up CMTA centres of excellence. So they're seeing patients every day with CMT. And they're the ones doing the natural history studies and tracking those patients. Because if you see, like, you get a score. So you do your CMT functional outcome measures and you get a score.
Mm.
And you could plot that on a graph, and over time, that score is probably going to get higher. I think that's the way it works. So, you know, you get worse because it's a progressive and degenerative disease. So you're probably going to get worse over time. And it's generally quite slow. So these studies last over several years, and you can probably plot a graph of somebody getting worse. But then if you have a treatment, what does that treatment do? How do we know if that treatment's working? Do they keep getting worse or do they plateau? Or in, you know, hope amongst hope, do they start to get better? So their score starts to go down. So they have less problems with neuropathy. You know, we need to have that natural history data because if we don't know if it's working. So the CMTA has 5 natural history studies that we're funding at the moment across the main types of CMT. So that we can chart that progress over time. And, you know, the patients in those studies and that data, that can then be used to inform clinical trials because it's like, this is the typical path of a person with this type of CMT. We've given them a treatment and look, their progression has changed. They've stayed the same or they've got a bit better. So that's a really important part of what we do. And then the other part, other objective of STAR, is biomarkers. So you might hear people use that word. It's like, what does it mean? Well, just talked about those functional outcome measures, those physical tests and assessments that they have you do when you go see a neurologist. They'll measure your progression over time. It takes years. It's a slow disease. We don't want trials to take years because if trials take years, they're really expensive and nobody wants to do them if they are many years and very expensive. Or some people will want to do them, but very few people. And we want lots of people to want to do clinical trials in CMT. So one of our challenges is how can we measure this progression quickly? Like, how can we give somebody this treatment and see really quickly if it's working? Well, for that, you need biomarkers. You can't just rely on those functional measures. So we look at blood and blood serum, and there's a really interesting technique that's been developed by the team at Queen Square in London that looks at muscle MRI. So they can take a picture of your calf and they can measure how much fat is in your calf muscle. And the amount of fat in your calf muscle is related to your CMT symptoms overall. So they've been able to correlate that calf fat, it's called calf fat fraction, but that MRI to the CMT score and show that, you know, the more fat is in your muscle, the worse your CMT score is. So those things are related. So that means you could actually use that MRI instead of. So you would still do the functional outcome measures, but they've shown with that MRI method, it's really exciting. They can measure significant progress, and in science, significance is important. Like,
Yes.
is it? Can you really tell it's different? But they can show that within 12 months, and they can start to be able to do clinical trials over 12 months with as few as 50 patients. So all of a sudden, clinical trials are easier, therefore cheaper. And that's exciting. So, you know, that's another part of the strategy is so you've got the discovery, you've got the understanding the causes, you've got the treatment approaches through genetic therapy, small molecules, then you've got the natural history studies and biomarkers. So that's the multi-pronged strategy. And the CMTA funds research across all those areas because there's no point having a treatment if you don't have natural history study data for the patient population that you want to treat. So all these things relate to each other, and you have to understand the disease really well if you want to treat it. So it's all related. So it's multi-pronged and it's huge. You know, it's been great to see it how it's grown over years as our understanding has improved and as science and technologies that are being used in other diseases, we start pulling them over to CMT and really taking advantage of those kind of scientific breakthroughs.
Amazing. Really, really interesting. Thank you. And you've highlighted a few of some of the research projects that are particularly exciting to you. I'd be really interested if you could pick a few additional kind of research projects that you're aware of that are really exciting you and talk us through them in a little bit more detail.
Yeah, absolutely. So I think at the moment, the CMTA has around between 50 and 60 active projects. So there's a lot
Busy.
to choose from. I think
Yeah.
it was 50 last year, we're up to about 60 this year. So um we're rolling on and rolling off projects all the time because they last anything from 1 to 3 years. So it's a constant moving beast.
Mm.
So some of the exciting ones, but that's really difficult because I'm not allowed to play favorites with my scientists. But we have just approved a nanoparticles project. So that's a co-fund with the MDA, the Muscular Dystrophy Association in the US. It's a $300,000 project over 3 years, and it's with a researcher called Alexia Kagavia, and she's based in Cyprus. So the CMTA funds research globally. We don't just fund research in the US. So she's based in Cyprus. She works closely with Cleopas Cleopa, who's a well-known CMT researcher in the field of genetic therapy development. So this is a nanoparticles project. Nanoparticles, small particles. It's potentially a way of delivering a gene therapy to the right part of the body that doesn't involve using a virus capsule. So some of the CMT genetic therapies that we're working on use something called AAV, which is an adenovirus virus particle, because they're really good at getting to different parts of the body. And essentially, they empty out that virus envelope, so there's no virus in it; it's just an envelope, and
Yeah.
they fill it with the gene therapy, and then they send it into the body.
Right.
Well, that's great, That's one way of getting your genetic therapy to the right part of the body, but there are other ways. So we're it's part of that multi-pronged strategy. We do not put all of our eggs in one basket, so we're also looking at nanoparticles. So you can join the gene therapy to the nanoparticle, and the nanoparticle is the clever thing that helps to direct the treatment to the body.
Fabulous. It's like
Yeah.
a taxi.
Well, I think of it like an envelope because we can put different things in the envelope. But the envelope, so there's different things in the envelope, and the envelopes can be different.
Yeah.
So we're experimenting on some new envelopes basically, and why that's exciting and important is because CMT is not an easy disease to treat. So
Mm.
it's a peripheral neuropathy, which means it affects the furthest parts of our bodies. So that's to think fingers and toes. Some of our neurons are 1 meter long. Like you've got to get that treatment into our body. You've got to get it to the furthest parts of our body
Yeah.
intact and functional.
Yeah.
And it's got to get across the blood nerve barrier. So some people have heard about the blood brain barrier. There's also a blood nerve barrier. It's what our body does to protect our nerves because nerves are important and sensitive and they're difficult to repair. So the body has this barrier in there to help stop like chemical exposures or nasty viruses from affecting our nerves. Well, that also works really well to keep treatments out. So we have to find a way to get beyond that blood nerve barrier all the way to the furthest parts of our body. And that's why we're looking at the nanoparticles or the AAV, those different envelopes. You can't just like swallow a liquid and hope that it's going to get to your nerves because, generally that just doesn't work like that. So some treatments will work like that, but genetic therapy treatments won't. Or you'd have to give so much of the treatment that it would become toxic. So, you need to be able to deliver a small amount efficiently so it gets to the right places. So that nanoparticles project's looking at that. So I'm really excited. We only announced that a few days ago. So that's a great one to be getting started.
And quickly on that, Katherine, as well, would that be potentially relevant to a whole host of different types of CMT
Yes,
kind of mutations, gene mutations? Yeah.
absolutely. Because if we can make the nanoparticles work, the
Yes.
target for this particular project is the Schwann cell. So the Schwann cell, if you think about a nerve, you all seen sort of pictures. We're in the CMT world, so you often see like artist diagrams of what a neuron looks like. So you see like the star bit at the end, and then do it that way. So that's like the star bit. That's the nerve bit at the end. Then the axon runs all the way down, and surrounding it is something called the myelin sheath. So the best analogy for that is like an electrical cable. Inside there's the copper wire. That's your axon, that's your nerve fiber. Surrounding it is that bit of plastic. Well, that's the myelin sheath. The myelin sheath is full of little cells called Schwann cells, and they make the myelin. So
Right.
most of the types of demyelinating CMT, like CMT, all the type 1s, so 1A, 1B, 1X, they're demyelinating CMT. So somewhere in there, there's a mutation that causes that myelin that insulating sheath, to go a bit wrong. And then that affects your nerve speeds. And it's the Schwann cells. So it's the Schwann cells that are expressing those genes. That's where the mutations happen. Well, so we have to get a treatment to those Schwann cells.
On shelves.
So
Okay.
it's the furthest part on a nerve, on the myelin sheath, in a Schwann cell. It's like having the longest address in the world, and you just need to, you've got to get to that one house and postcode. So we've got to get it all the way to there. So yes, if we can use these nanoparticles and they work in the models that they're testing it in, so they're going to be testing them in CMT1X models. But if they can get it to work for 1X, well, then they've got to a Schwann cell. And if they can get to a Schwann cell, then all of the other CMTs that are Schwann cell
Related.
derived, that can be used for them. So the nanoparticle envelope will work, but then what you put in the envelope, you would put a 1X treatment in the envelope, you could put a 1A treatment in the envelope, you could put a 1B treatment in the envelope, because they all need to go to the same place. You just put something different in the envelope. So yeah, that's why it's exciting, is it could then be applied across anything that's Schwann cell involved. And that's a lot of CMT types.
Amazing. Thank you so much. And you can really tell that educational background because I can follow that. So I'm hopefully our readers will also get that's brilliant. Thank you. Now I'm really conscious of time. Do you have a few
Yep.
more minutes with us? Is
Yeah,
that
absolutely. I can be here as long as you want me.
You're too kind because this is just fascinating. I could dive into, so many more of these areas, but um, I guess it'd also just be interesting to hear. You've highlighted some of the research projects. Sort of what developments do you anticipate? And this is a harder question, but what would you anticipate developments in diagnosis, treatment, or management of CMT that we might expect in the future based on the research projects that are happening now? So you've highlighted a few, but is there anything else you'd want to bring?
Yeah, I mean, well, personally, I think because we're at the dawn of treatments, like there's two clinical trials at the moment in phase 3, one for a drug for CMT1A, one for CMT SORD. You can only access those treatments if you know what genetic type of CMT you have. And traditionally, like not a lot of people have genetic testing. So they might know they have CMT from some of their physical examinations, but they might not know what genetic type they have. Well, there's a huge motivator once we call them subtype specific treatments. This isn't a general treatment that anybody with CMT can take. They are treatments focused on 1A, 2C. So I think what I see changing is an increase in genetic testing and an increase in access to genetic testing. Because as soon as there's a treatment for a particular type of CMT, you need to show you've got that type to be able to access that treatment. So I can see more genetic testing becoming available and there'd be reasons for it. And then potentially we won't have to argue so much for getting our children tested because there's treatment. And often with these treatments, if they can be expanded to pediatrics, the earlier you can have that treatment, the better, because you'll have progressed less. It's a progressive degenerative disease, biologic, the earlier you can get that treatment, the better. So I think we'll see more genetic testing, and I think we'll see it being available younger. And then also knowing sort of treatments, like what's going to happen with treatments in future. That's one of the most exciting parts about my job is I can see the pipeline, I can see behind the scenes, I can see treatments are coming. There will be new clinical trials starting in 2024. It's companies that we're working with, I know that they're planning them. We have to see what happens because there's always hurdles to overcome, but they are being planned. So we'll start to see more clinical trials. I mean, there's been handful up to this point, but what I'm seeing is it's really going to expand because those trials can be shorter, they can be fewer patients in them, they're more accessible, technology is advancing. So yeah, treatments are coming, and I think they'll come in my lifetime, and I think they'll definitely come in my son's. We just have to keep the momentum going and keep supporting these companies and researchers to make sure they've got what they need to do the research. And then in terms of management of CMT, is the pool of specialists we have is growing. I mean, at the moment, all we can do is manage. So, your ankle and foot orthosis, your walking aids, surgeries for people who have orthopedic involvement where they've got the contractures and feet and hand operations, things like that. We're learning more about that all of the time. And then just more knowledge on the benefits of physiotherapy and exercise in CMT. Like, we're doing our best to share that as much as we can, but there are amazing therapy teams within our neuromuscular centres that can really help with the types of exercising and things that we can be doing to live well with CMT for longer. So I would say, like, seek out the CMT specific exercise videos. We have loads on our website. There's a whole series of them, that are all available for free. So it's like, start to look at those things and the things that you can do now to. I was told at a CMT support group meeting I went to in Yorkshire, it was organised by CMT UK. There's a lady, like, literally grabbed hold of me and she said, "Keep active, use it or lose it." And I mean, that really stays with me. So, and there are physiotherapists, therapists who can help us with that day-to-day management and staying as active as possible. So I would say that that's advancing as well, and the knowledge of what you can do, and it is safe to exercise with CMT, just like keep at it and try and stay active. So that's been promoted more as well.
Brilliant. Thank you so much. Really interesting. And yeah, key takeaways: keep active, get tested, speak to your clinical team, find out what that gene mutation is, and that knowledge is power, and hopefully will help to access future support, future treatments for you and your family. Listeners, brilliant. Thank you so much. So just quickly then, I'd be interested to hear, for readers or listeners, watchers, that are interested in either participating in studies or reading up on the various topics, where would you direct them to kind of access that information if they want to learn more in detail about research?
Yeah, so I feel them because I love to dive down that rabbit hole too. So um, on the CMTA website, we have a whole section called Patients as Partners in Research,
Mm-hmm.
because the research can't happen without all of our community, without all of the CMT patients stepping up. So we have on that site, I think, 14 at the moment, active opportunities for people to get involved in some of the natural history studies that I talked about. It might be a survey, it might be a breathing study, all different types of CMT are on there. So I'd say have a look, see what the opportunities are, see if there's a centre near you where you could join it. Also on there's an opportunity to build a profile, so people can build their own patients as partners in research profile. We need everyone to do that. We've got 6,200 people with CMT that have done that so far, and that's the largest patient reported data set on CMT that there is globally. The more people who fill that in, the more we understand about what type of CMT you have. How old were you when you were diagnosed? How old were you when your symptoms first started? All this information is so important to build that profile. And when you've build that profile, you get the opportunity to say, yes, I'd like you to send me a star e-newsletter. And then once a month, we'll send you an email that says about those projects I've just talked about. Here's a new project on nanoparticles. Here's a new project on antisense oligonucleotides or genetic therapies for CMT. Here's a whole article explaining what an antisense oligonucleotide even is. So we have those, we send them out once a month, and it details some of our research projects, and it has links to our website. And on the CMTA website, we have a section on each type of CMT, and we have a summary of what research we're doing in those types. So that's like a whole repository, and just dive on in, and it's all written in a really accessible way. And then, if you want to, you can go into the research papers, but we generally don't share the raw research papers because they're written for scientists. So the CMTA website has it all translated into human language so people can understand. And also things like we have a lunch and learn education series. So we have webinars. We're running one this afternoon. And we have 560 people who've signed up because it's a 1A research update. And we've got 5 people speaking on what's happening in 1A. We've got a company talking about their treatment development. We've got the chairman of our board. So, if people like to come to listen, then there's things like that. And we put copies of those on the CMTA's YouTube channel, so people could just come and listen. So if you miss one, you can listen back. And it's a huge repository of information. So that's a handy place to find out more as well, straight out the mouths of the scientists and researchers.
Amazing. Thank you. That's really, really fascinating. And I think lots of our readers will be interested to learn more. So just to round off, we talked a lot about kind of your work in detail. Hopefully people will know where they can go to find out a little bit more. I'd just be interested to end on a personal note. So you operate in a really academic and rigorous world. How do you personally like to unwind after a long, busy day, switching off from this vast world of research and experimentation and science? How do you unwind with your family?
I don't know if I would ever call it unwinding because so I have a 5-year-old and an 8-year-old, so they don't unwind you, but they are definitely help you switch off because they are all consuming, so they will suck you into their world. So I will Lego with my son. My daughter really likes to sing, so some kitchen discos. We love a kitchen disco in our house.
Love
But my happy place, how I completely switch off my brain is I dance. So I learn salsa dancing during my PhD, and I had lessons and went once a week for about 4 years, and I loved it. And then marriage and kids and work and all of that got in the way. But actually, a friend of mine who I learned to dance with just moved back to where we live in Yorkshire a few months ago now, and we picked it back up. So every Sunday there is salsa in my kitchen, and once a month we head out and dance. And it's been so good for my balance. I could not believe how rusty I was when we restarted. I cannot dance in heels anymore. No more fancy salsa shoes. That's gone. But I can dance in socks in my kitchen, no one's watching. And occasionally, I kind of have to hold on to the fridge. But that's less. I mean, months
it.
in, yeah, we're months into training and we do treat it like training. And I haven't fallen into the fridge in weeks. And
Amazing.
then I've picked up going to the gym. So I'm always really inspired by CMT athletes and people who are keeping active as to what you can do. So gym's usually a weekly affair. And also Camp Footprint introduces you to all sorts of like physical activities. So first Camp Footprint last year in 2022, I tried paddleboarding for the first time. And it turns out that a really good friend of mine here in Yorkshire, she loves to paddleboard. So I've been going out with her. So occasionally fall in the river, but it's okay. And I can kneel on a paddleboard if my
I was going to
balance is
say, for
that
me,
high.
yeah, it's a kneel when I paddleboard. I can't stand, but that's fine. Still
I
exercise.
don't, yeah, absolutely. I don't call it stand-up paddleboarding. It's paddleboarding any way you can. And this week
Lovely.
it was windy when we went out, so I spent most of it kneeling. So yeah, trying to stay as fit and active as possible, but I like to do that with real life people. I know that sounds strange because a lot of my work is people on a screen because it's international. So
Yeah,
I quite like to do my sports with humans in a room with them.
tangibly.
So yeah, dancing in the gym or on a paddleboard. It's nice to be out and mixing with people and trying to stay fit and healthy. So that's how I switch off from my work. So yeah, it keeps me busy, but it's good fun to keep active.
Brilliant. What a fascinating dive into your world. Thank you. Is there anything else you'd like to share or close on while we wrap up?
No, just to say that it's been wonderful in this role with the CMTA, working more closely with CMT UK. Simon Bull and I usually catch up at various conferences because like a lot of my world is meetings and computer based, but a good week of the month I'm usually traveling to a conference, and that's in the States, in Europe, in all over the place. So it's been nice this last few months. We've had a few UK based conferences and I've been able to connect with Simon. So just building on that, because to steal the phrase that the European CMT Federation uses, and I really believe it to my core, is that together we are stronger. So we can keep pushing CMT research forward, but that's only if we work together. Like every single bit of the research I've mentioned today, it's funded by the CMTA, that's funded by CMT patients. They donated $10 million last year. We were really surprised. I spent 4.8 million of that on research just in a year. We're going to try and we'll be doing more this year. That's like my effort, more research. All of that is only possible by the whole CMT patient community coming together, supporting what we do, sharing our posts, like cheering the researchers on, funding the research. So just say we can only do this together. So it's brilliant to be connecting with CMT UK and pushing that direction, linking the UK scientists fully. They're fully linked into what we do at the CMTA. So it's just good to bring all the communities along together. And I hope to see more of my CMT UK friends at Yorkshire branch get-togethers. I've been to a couple of those, and let's just keep pushing it together, and we're going to get there. Like, I have every confidence that we're going to get there, that we will get treatment. So in the meantime, we just keep supporting each other.
Thank you.